Hello students, in this video we'll discuss cardinality of sets. We say that a set has finite cardinality if there are only a finite number of elements in the set. The cardinality is the number of elements in the set. So cardinality is the number of elements in a set if the set has finite cardinality. So let's write down some examples. So the cardinality, I'll write that as CARD, of the set of points 2, 4, 6, 8, 10, that's a set of the first 5 even integers, and so the cardinality of this set is 5. I can look at something like this. I can say the cardinality, I can do it with a set builder notation of the set of points x such that x squared minus 5x plus 4 is equal to 0. So I'm looking at the set of all points x that satisfies this polynomial equation. Well, we can easily see that we can factor this as x minus 4, x minus 1. And so in particular, there's only 2 numbers x that are real numbers that satisfy this equation. So the cardinality of this set is equal to 2. They don't have to be numbers in our set. We can say the cardinality of the set Jack, Queen, King. This is a set with 3 members, Jack, King, and Queen, so the cardinality of this set is equal to 3. So in general, if a set has finite cardinality, all you need to do is look at the set and find all the elements in the set. Sometimes it'll be explicit, as in these 2 examples over here. Other times it'll be implicit with something like set builder notation. You have to actually satisfy a condition to find out the number of elements in the set. Now we can transition to the notion of infinite cardinality. We say that a set has infinite cardinality if it does not have finite cardinality. We need to get used to these infinite cardinality sets too. So for example, I can ask the question, I can say, let's find the cardinality of the set N. And what this is the cardinality. And N is going to be the set of counting numbers 1, 2, or natural numbers 3, 4, etc. And clearly the counting numbers go on forever, so we say this is infinite cardinality. Say infinite cardinality. And we can be more specific about this. The cardinality of the natural numbers is called countable. So this is going to be a countable infinity. This is a countable infinity. Whereas we can consider the set of real numbers, the cardinality of R, which is the cardinality of the set of all x, such that x is a real number. Is a real number. And this is also infinite cardinality because, in particular, all the real numbers contain all the counting numbers, or the natural numbers. So this is infinite cardinality. And it can be shown in a class in analysis that this set is uncountable. It's an uncountable infinity. We won't show that in this class, but suffice to know that there's different infinite cardinalities. So when can we determine when two sets have the same cardinality? We say two sets have the same cardinality if there is f mapping a to b, if there's a function mapping a to b, and f must satisfy two conditions, where f is 1-to-1 injective and f is onto. So they have the same cardinality, or equivalent cardinalities, if you can find a function that's 1-to-1 onto, which means that every element in B comes from an element of A, and if two elements in B came from the same element of A, those two elements A have to be the same. In other words, there's a 1-to-1 correspondence and an onto correspondence from the set A to B. In that case, they'll have the same cardinality. It can be shown that the counting numbers, the natural numbers, 1, 2, 3, 4, 5, etc., cannot be mapped in a 1-to-1 onto fashion onto the set of real numbers, and that shows that those are sets of different cardinalities. Thank you very much.